Hello everybody and welcome to BS Math. Today we're starting a new video series about Calculus 1 and 2. So this first video is meant to be an introductory video. We're going to talk about the topics that we're going to cover, the style in which we're going through these different topics, and also the relevant prereq knowledge that you should know if you're going into calculus. So as you can see here on the left, I have the list of topics. We're going to go through limits and talk about your limit properties, product difference quotients of limits. We're going to talk about derivatives and all of those properties as well, the things like the power rule, the product rule, the chain rule. We're going to get into derivative applications with, let's say, related rates and implicit differentiation and optimization. From there, we're going to move to integral calculus and talk about the definition of an integral with a Riemann sum. We'll look at integration techniques and applications. We're going to move to separable differential equations, and then from there we'll talk about polar and parametric calculus. Finally, we'll end off the series by talking about Taylor series. So if you'll notice, we have a bit of a color coding thing going on here, where there's some blue dots, some green dots, some red dots, and what this is saying is everything in blue, so limits, derivatives, and integrals, are going to involve a lot more formal definitions and proofs. Specifically, limits and integrals, where we're looking at what it really means for a limit to exist with epsilon delta, or for integrals where we're looking at Riemann sums. This means that if you haven't had proof experience, this might be a little bit more tricky, but with some practice, you'll get used to it. All the stuff in green, this is your derivative applications, differential equations, and polar and parametric calculus, are going to rely very little on proofs. It's mainly going to be building on previous work and looking purely at procedural stuff. Finally, integration techniques and Taylor series, in red, are going to be a combination of your formal definitions and non-proof based work. So we're going to develop some formal definitions with things like U sub or the idea of a Taylor series, but you aren't going to need to do as many proofs as you will for limits, derivatives, and integrals. Finally, for prereq knowledge, there isn't that much. The only thing that you really need to know going into this is know about basic functions. And what I mean by that is if I were to give you a function like f of x equals e to the x, you need to be able to A, tell me what the graph looks like, but also know all the relevant properties about e to the x. You should know that e to the a plus b equals e to the a times e to the b. If I were to give you, let's say, sine of a plus b, you should be able to tell me that this is going to be sine a cos b plus sine b cosine of a. You should know your Pythagorean identities, like sine squared plus cosine squared equals 1. The reason I say that is because a lot of calculus isn't just doing calculus with derivatives and integrals. A lot of it is algebra, and a lot of it is manipulating equations. There will be plenty of times, especially with things like integration techniques, where the path forward is a lot easier if you know all these little properties about different functions. So sometime in the future, I will make a video series talking about this prerequisite knowledge, but the more you know about your trig functions, your exponential functions, your log functions, your rational functions, the better. With that being said, that wraps it up for this introduction video. Next video, we're going to be talking about the intuitive idea behind a limit, and from there we'll move into formal definitions. Hope you guys have a good day, and I hope to see you there.